x squared plus 5x is equal to 24. X squared plus 5x is equal to 24. So it's saying that we begin by rewriting the equation so that the right hand side is 0. So having x squared plus 5x, you will bring the constants at the right hand side to the left hand side so that the whole equation will be equal to 0. So in this case, we will subtract 24 from both sides. Then we'll end up getting x squared plus 5x minus 24 equals 0. So in this case, A is 1, B is 5, and C is minus 24. So the first step is make the right hand side 0. Then to the factoring, you look for, I know this one we should know, you look for two numbers that their sum will be equal to the B and their product will be equal to the C. It is not stated, I think, here. So we factor the resulting equation by looking for two factors of 24, whose sum or factors of 24 that add up to 5. That's what is in your book. But into a layman, you look for two numbers, and when you add, you get the B. So if I should go back, if you are factoring two numbers that can help you get, when you add them, you get your B. When you multiply them, you get the C. Two numbers, when you add them, you will get B. When you multiply them, those two same numbers, when you multiply them, you get the C. So for this example, we have minus 3 and 8. Minus 3 and 8. These two numbers, when you add them, you get the B. When you multiply them, you get the C. So then you put 8 in place of the B. So you realize that instead of the x squared plus 5x, we put those two factors there. The minus 3 and 8. So with these two, now you can try and factor out. So we factor out x minus 3 plus 8x between 8 into brackets x minus 3. So when I say factor out, the x squared plus the first part of the B and the last part of the B and the C. So you do this factorization, you end up getting in the brackets, you end up getting the same, I would say, like terms. So you realize that we have x minus 3 in this bracket, x minus 3 in this bracket. So the common terms, you put them together, which is x minus 3. Then the remaining ones, also you put them together, x plus 8. You put them together. So you get this x minus 3, x plus 3, which are the common factors of the equation that was given. Now, if you want to apply the zero product property for each of the terms, you equate it to 0, and then you make x the subject. So here, for this particular term, x minus 3 is equal to 0, and for this particular term, x plus 8 is equal to 0. So you get x is equal to 3, x equals minus 8. This is how to solve that quadratic equation using this zero product property after factorizing. So the most important thing is to find those two numbers that when you add, you get the B, when you multiply, you get the C. Note, why one side of the equation must be 0. If we had proceeded by factorizing the equation as it was given, we will not get anywhere finding the solution, because 24 can be factorized in many ways. So a quadratic equation of the form s squared minus c equals 0, where c is a positive constant, we factorize it into this. So the aim is to get something like 2 terms like this and equate it to 0. And each one of them, we take and equate that to 0. So in this case, the x minus square root of c, like what we did with the minus 3, this is what we get. Then equating this also to 0, we get this. The other methods for solving quadratic equations. So we have an example here, x plus 1 all squared plus 5. How do we solve this? So in an exam or quiz, you will be given expand this. How do you solve this? This is also a quadratic equation. It's saying that we begin by expanding the expression inside the bracket. Expand the equation, the expression inside the bracket. So x plus 1 all multiplying another x plus 1. And mostly when the expression is of this term, you are likely to get this. So last week, I know maybe that was what some people were using. And I said, be very sure. If you know this, yeah, that's fine. You can easily say maybe x squared plus 2ab plus b squared. You can easily say that, but then be very sure. If you're not too sure, please expand your bracket. X plus 1 into bracket, all multiply x by 1. Then do it step by step. But then for those who know and they have been using it, they can straight away express this in terms of this. In terms of this. So back to the question, x plus 1 all squared plus 5. You are likely to get this. And you realize that this is of this form. So x squared plus 2x plus 1. If you don't know, we can easily do our x plus 1 into bracket x plus 1. If we are to solve, we get x squared plus x plus another x plus 1. If you put them together, that's where you get the x squared plus 2x plus 1. So this expression is the whole of this plus the 5. We have expanded the brackets. So after expanding the brackets, you realize that you get the plus 1 plus 5. Should you remove the bracket here? You get plus 1 plus 5, making 6. So meaning that the above example shows that this can be written as that. In this section, we are given the expanded version and we try to rewrite the expanded version as the question given. In other words, we go from solution to the problem. So it is trying to say that the question can be to express this in another form. This is a problem, and we are to expand it. And the expansion of this is the x squared plus 2x plus 6. So what it is trying to say is now you will be given the solution to express it in another form, of which this is the other form. So that is what it is trying to say here. Express expressions of this nature. This is equal to that. We also refer to them as identity. The term identity means that two mathematical expressions are equal for all values of the variable. So the following are some examples of identity. So we see this is equal to that. That is equal to this. this is equal to this. Now, if you carefully look at this, you realize that something interesting is going on. And it's written here, I'll read it anyway. You realize that if you are given the answer to find the problem, in other words, moving from the solution to the problem, if this, we take this as a solution and we want the problem, you realize that the B part is always like in the problem. You take it and you halve it. You take it and you halve it. If you look through all of them, 4 is here. You halve it, you get this one here. You have -5, you halve it, so you have -5/2. 7, you halve it, you get 7/2. So for those who want shortcuts, if you are given the expression to find it or put it in another form, quickly, this should give you a clue as to what will add to the x in the bracket all squared. It is the b part divided by 2. But we'll go through how to get the other expression. Divided by 2. And then our problem is to find this other. So how do we get the -3? How do we get the 17 or 3 or 4? We'll find out how to get that. Can you notice any relationship between the left-hand side and the right-hand side? If you look at the coefficient of x of the expression on the left-hand side, and if we look at the number inside the bracket on the right-hand side, you will notice that the number inside the bracket is half the coefficient of the variable x, the one I was referring to as BBB. In the first example, the 4 is half of 4 is 2, -5 to 7/2. So let's consider the example. X squared plus 4x plus 1 is equal to this. We know that the number 2 inside the bracket is half of the coefficient of x, which is 4. But then where did the other one come from? So like I'll say the rest, the -3, -17/4 plus 3/4, where did that one come from? So let's get into that. Now we have, repeat this again, a plus b all squared is equal to a squared plus 2ab plus b squared, with a equal to x and b equals to 2. Yeah, so we'll get this. So it is actually working on this side. So meaning that to expand the x plus 2 all squared in this form, we know that we have x squared plus 2ab, in which b in this case is 2. So it will add up and give us the 4x plus 4. Or if you are still confused about how this is equal to this in terms of having this and putting it in this form, please expand your brackets yourself. Expand your bracket yourself. So you have x plus 2 multiplying x plus 2. We get what? X squared plus 2x plus another 2x plus 4. And if you further simplify, you get x squared plus 4x plus 4. So the x plus 2 all squared is what gives us this. It's what gives us this. And for those who know it, you know that if a is equal to x, then that means you have your x squared here plus 2x plus a is equal to x, and your b is 2. So that will give us a 4x. And if b is 2, this side will give us 2 squared, making 4. But like I said, if you can't memorize that this is equal to this, it's not even important. Expand the bracket yourself. So this part, this expression is what we have here. Now it says we have x squared plus 4x plus 1 is equal to this, of which not entirely true according to the book or the model, because this whole thing is equal to this, which is just the expression minus the 3. So the minus 3 should have come. This is not equal to that. This expression is equal to that expression. So you can't just take this one alone and say this is equal to that one. So there should have been the minus 3, but it didn't come. So yeah, I continue to say the same thing, but I don't think it is right. The whole of this expression is equal to that expression. So you can't drop the minus 3. So here, okay. So it had, yeah, the minus 3 should have come. So it came, and then so for this part, it was this minus 3. So you should have the whole of that minus. So we subtract the square of half the coefficient of x, and half of 4 is 2. Subtracting the square of 2, which is 4, from the right-hand side of the equation. Okay, so this is the whole expression is this. Then when it came here, the 4, which is the b, the coefficient of x, you halve it. So 4 divided by 2 is this 2. And it's saying that subtract the square of after the half. So the same half, which is 2, you square it and subtract it from the right-hand side. So that we have a minus 4 over here. So where is plus 1 is coming 4. Square minus 4 plus 1, giving you the minus 3. So in actual sense, if you take the coefficient of x and you halve it on the right hand side inside the bracket, you get 4 over 2 all squared. Then that same b, the coefficient of x, you halve it and you square it at the right hand side. So if I take 4 and I halve it, I get 2. I square that 2, I get 4. Subtract it from the right hand side. So there's the minus 4. Then I guess he's bringing this plus 1 here, getting the minus 3. But I am taking that straight away. If he had brought the minus 3 just like the way it was, this would have been much simpler. But then I have my own way. Of teaching this one, and I'll teach you. So let's move on. If you have this, what I was doing is pick the b at the right hand side inside the bracket, subtract half of b. So you have x, and b is minus 5 in this case. So you have minus 5 over 2, x minus 5 over 2 all squared. Then the same b, subtract it from this side. Subtract it from this side. That is your plus 2. So this whole side is what you simplify. So it gets 25 over 4 plus 2. If you should simplify this one downwards, you will get the 17 over 4. And that is how come we get those constants. Let me go back. Those constants, these ones, the minus 3, minus 17 over 4, minus 3 over 4. So if we have this, wanting to express it in the form of this, for the first one, you have your x plus coefficient of x, the b, divided by 2 all squared. So in place of whatever is here, it is 4 over 2 all squared, and 4 over 2 is 2. Then the coefficient of b again, you take it and subtract it. So you'd have 4 over 2 all squared minus plus 1. So you don't have this yet. It's just this that you still have plus 1. So you have 4 over 2 all squared is 4. 4 minus 1. I don't know if, let me. So it's we have what, x squared plus, please, do you understand?
Yes, we are following.
Madam, we are following.
Okay, so I am
Hello,
trying to
madam.
do just this one so that, hello,
Madam, we are on point. We are on point.
okay, minus 3. So, for those who are lost, please, I'm going through this. It's a bit some way. We may be given the answer. You see, the question was expand this. But then it is saying that sometimes you may be given the answer rather. If you expand this, you will get this. And then it is saying that you may be given the expansion rather to put it in another form. And the other form is this. Because these two are identical. So the identity expressions or equations. So now how do we go from here to here? This is what we are doing. And then, so it says like, the first thing is to get this part of it. What you do is, in this expression, pick your b part, or more appropriately, the coefficient of x. So this 4. And you have it. So the first thing that you're going to get is x. The coefficient of b is plus 4. If it is minus, don't forget the minus. If it is plus, maintain. Plus, it should be, please allow me to use this. It should be 4 divided by 2, all squared. So this is how to get this part of the equation. So if you are given this, how do you get this part of the expression? Your x comes plus, the plus is coming from, because the coefficient of x is plus 4. If it was minus, it would have been minus 4 divided by 2 all squared. So the expression, the x here, the squared here is a constant, but you just want this value here. And this value is coming as a result of the b divided by 2.
No, please,
Please,
with
is that clear?
the whole square, I think there should be another bracket after the 2.
Okay, okay. So that is how we get this part. Now we are interested in getting this part. How do we get all those constants? This is how we do. So after getting this part is, you see, your plus 1 will come. So still having your mind on the right hand side, this is what you do. It wasn't supposed to, but I don't know how to, if it was MS Word, it would have come down, but I don't know how to do it. So what you do is, it's saying that subtract. So you have your plus one there already. So you have your plus one there already. From here, you have your plus one there already. Now it is saying that this coefficient of b, subtract it from the equation. I mean, you are building this. So you have the same principle here. We were supposed to do, so let's say it's a plus one is there. We do a minus 4 divided by 2 all squared. So I would say that inside the bracket here, you do a 4 over 2, and then all the bracket all squared. Then you subtract that b over 2, you square that, you subtract it from the right hand side. So this would give us, this whole thing here will now change to will now change to 2 squared. 2 squared. Now this 2 squared, you realize you get 1 minus 4. So this 1 minus 4 part is where the minus 3 is coming from. The minus 3 is coming from. And then I still feel this is a bit complicated, because I have this. Well, it's still the same thing anyway, but when we go to completing the squares, you realize, maybe you probably understand how the constants are got. So this the other example. There were 3 of them. So there's a second one. How did we get this, or how did we go from the expanded version to this expression? So you have this, realize that what we did was take the b, in this case it is minus 5. So we have x minus 5 over 2 all squared, getting the first part. Then the same 5 minus 2, square all of that, plus this 2. So we have the first part. This part here, if we should open the bracket, we get 25 over 4. 25 over 4. You simplify this part going, and then you get your minus 17 over 4. So you move from there. That's how come we got this constant. We got this constant from there. And then the third part, the third question or example, this was the expression, and we have to express it in another form. So the same process. Take your b, divide by 2. So your first part, x plus 7 over 2 all squared. Minus, so you subtract this part, what you did inside the bracket here. Take the same thing, and all squared plus your c to bring it. So when you simplify, this becomes 49 over 4, and then find the least common multiple and simplify this part. And then we have put this into another form. Is there any question? Is there any question?
Yes, madam. Please, with the first one, we were supposed to subtract 4 also from the right-hand side. And when we subtract 4 from the plus 1, it will be negative 3. And somebody also said that we should introduce another bracket. Please, may I know why?
Oh, no. No, not introduce. He was just correcting. This was 4/2. So this bracket was for that bracket. That's the closing for this opening. So he was just drawing my attention that this, I should close the first one that I opened. Because it is x plus 2, all of them squared. If I leave it like that, that means the square is only affecting this one. And that is not it. So the introduction of the bracket is the way I wrote this. If I had a better way, if I remove this, that means I need to set coefficient and then. So this would have been the 4 over 2. So this one, no introduction of any brackets. It is, I have closed the brackets. This one is closed here. And it's all of them squared. Just notice here. So this 2 is as a result of this b over 2. So x plus 2 all squared. And then it's not subtracting of 4 per se. That's why mostly, if I had time, I go through the models and do my own notes. But this one I didn't have time, so I had to just copy and paste. It's not subtracting of 4 per se. But whatever you did inside the bracket here, subtract it. So we were subtracting minus the same minus 4 over 2 all squared. We're subtracting it from let's say the left hand side as well. So we have put this. We have put this whole thing, the first part. We got it from this x plus the coefficient of x all squared. And we are supposed to subtract the coefficient of x all squared from it as well. So this plus 1 is coming from the same equation here. And whatever we did, this 4 over 2, we subtracted it, but you need to square it first. So 1 minus 4 over 2 all squared. Now this gives us 4. If we should solve this part, this gives us 4. So we will get, let me copy this one. And then this, if we simplify, gives us 4. So 1 minus that 4 is what gives us this thing. So then we have put this equation in this form. Please, are you clear?
Yes, madam, but that will be different from the first one we had. Initially, we had plus 3, and we are getting minus 3 here.
Plus
That
3,
is
really?
yes.
This equation.
It was where we are coming from. It was 3. Sorry, x squared plus 4x plus 1 is equal to bracket open x plus 2 bracket close square all square plus 3. So after we have gone through all this procedure, we are getting minus 3 instead of plus 3.
Please hold on. Why did you get a plus 3?
From the first one. Oh, really? Okay.
This was different. So it started from here. So we took the first one to solve.
All right,
the
madam,
first
please.
one.
I've gotten that.
Okay.
Thank you so much.
So going through the second example and the third example is the same thing. We are given this to put it in a different form. Take the x, you have your first x, my concern with students is when I say take B, they only watch the number here and forget the sign. Please don't forget the sign. If it is plus, make it plus. If it is minus, make it minus. Because the coefficient of this x is -5. But students mostly forget and they forget the sign and they take only the number. So it is -5 now. I have to divide it by 2. So the first part of it, it gets x -5/2 all squared. The other part is to take the coefficient of b divided by 2 all squared, subtract it from it. Then in your original expression, whatever was there as a constant, bring it and simplify. That is how you get the constant in the expressions given. So the -3 here, -17/4 plus 3/4, all this is coming as a result of taking the coefficient of x divided by 2 all squared and simplifying with a constant in the original expansion. Okay. So what we just did, or what we just went through, is called completing the square. Completing the square, and it results in an algebraic identity. So we have what you have on the left hand side is the same as what you have on the right hand side. The following expressions will be helpful. So the first one, we have met it, and I'm saying that please, if you can't memorize this, it is not by force. Once you know how to expand your bracket, it is okay. But then these are expressions that if you know, it makes you a bit faster in solving your problems. So you have this is equal to that, this is equal to this is equal to that. But I'm saying again, if you can't memorize this as this, when it gets to that, expand it and you get this. Okay. So complete the square on the following quadratic expression. Complete the square on the following quadratic expression. Can we try the first one before we go to the answers? Or let me let you try the first one.
Sure.
Okay, no, wait. Let's all do the first one. Let's go through the solution. Let's B and C, and I'll let you try. Okay, so that's what we were doing. B is -8, half of it is -4. So then what did we do? In here, x -4 is not minus, the -4 is coming as a result of what? 8 divided by 2. 8 divided by 2. Minus, so once it is 4 here, oh, the B is also here. Okay, the C is not here, so you do the C. So this 4, this 8 divided by 2 is 4. This 16 is coming as a result of the 4 squared. You realize that in subtracting, you will square the half that you are bringing. So the 4 all squared here, which you were supposed to subtract, is the one giving us a 16. We will simplify and you get this. So this is also this. The B part, we have this, and we want to complete the square. So in that case, what do we do now? You see here, it is very some way. The 2 here is not making the coefficient of x squared 1. And before we complete the square, please make sure the coefficient of x squared is 1. If it is not 1, make it 1. If it is not 1, make it 1. So we need to make sure the coefficient of x squared is 1 by factoring 2 out. So the equation, we just factor 2 out. We have x squared minus 5. So it's like divide 2 by 2. Minus 5/2x plus 3/2. we did nothing but just to factor 2 out. So now this is what we are going to work with, the one inside the bracket, still maintaining the 2 outside. When we finish, it should come. So inside the bracket here is what we are going to complete the square. And this is A minus 5/2 is B. 3/2 is C. So when we pick B, for instance, minus 5/2, if we should divide it by 2 again, we get that minus 5/4. Minus 5/2 divided by 2 gives minus 5/4. I think there's a topic in there where you understand that why it is 5/4 now. Because if you have a fraction, 5/2 divided by 2, you know, mostly every whole number is over 1. So 2 is like 2/1. How do you solve this fractions? You have 5/2 multiplying, then you take the inverse. The division will change to multiplication. Then the 2/1 will now be 1/2. Please, do you understand what I'm saying? Oh, we are lost. You have 5. Oh, sorry. How do I get the division? Okay, you want to divide this by also get the division. So please put it. So you have the 5/2, and now because it changed, the division changed to multiplication. This is what you get, and then finally you get the 5/4. Please, I hope it's clear.
Yes, please.
Okay. So this is how come now inside what we are subtracting became 5/4, because we took the B, which is minus 5/4, and divided it again by 2. So we have 5/4 all squared as the first part, and then we subtract it all squared from it. The constant here came, and then you have to simplify what is here. So we have like minus 25/16 plus 3/2. Should you simplify this? You get minus 1/16. And then if lastly you want to expand the bracket back, you have 2x minus 5/4 all squared minus 1/8. It's 1/8. So the underlying principle is the first thing, make sure your x squared is 1. The coefficient of x squared is 1. If it is 1, then it's 1 is fine. If it is not 1, factorize it out. Now, if it is 1, what you do is look at the coefficient of x. Take that one, divide by 2. So for your first expression in the answer you want, it is x. I don't want to say plus or minus, but depending on your value of b, you take that one, you square all of them, x. So in this case, x minus 5/4 all squared. Whatever you did to b, which is divided by 2, you square all of that and subtract it from the equation. And then you are good to go. So let me go back and then please simplify or complete the square on the C. Let's give it a try. Let's give it a try. Or will somebody try for us?
Yes, please, madam.
Okay. Please, I'm going to me. I like writing. So let me look for my paper. Okay, please go ahead.
Okay, so we will have 10. First of all, we will write the main equation and equate it to the one I will be saying. So the main equation will be 10 minus 6x minus 3x squared equals 10 minus 3. So in this case, I have taken that of minus 6x and minus 3x squared, and I have factor 3 out. So I factor 3 out where I factor minus 3 out where I got
Exactly. So please, the first thing is let us rewrite it so that you'll understand. So whatever is here is equal to minus 3x squared minus 6x plus 10. So that somebody doesn't get confused, because always the x squared is the one leading. It's a polynomial. So ideally, if you leave it like this, it's fine, but mostly it is in this form.
okay.
The higher the powers, they are in front. So the first thing that you need to do is to rewrite it well.
Okay.
When you have the minus
Okay.
3x minus,
Minus
minus 6x plus
plus
10.
10.
Exactly. So let's go from there.
Okay, so if you have to go from there, then we have I'll factor 3 out, minus 3 out. Then I'll have into brackets x squared minus 2x minus 10.
Hold on. If you are factoring minus 3 out.
Sorry, plus 2x.
Okay.
Plus 2x. Then minus 10 out of 3.
Okay.
So when I got that, then a bigger bracket,
Okay.
then I'll have x plus 1 all square where I took the 2, the b. Then
Okay.
I find half of it and I squared it.
Okay.
Then so in that case too, the minus 3 is still out.
Yeah, it's still out. So you're
Yes.
working inside.
Yes, please. Then we will have so now I'll repeat the minus 10 out of 3. Then I will subtract the square of the square of 1. That is the one I got, the half of 2. I'll subtract it. So I'll have 1 square is 1.
Yeah.
Yeah. Then I'll close that bracket. I'll close the whole bracket.
Okay. So then what do you
Madam, I
get?
thought, okay, so then when I close all the brackets, I'll also bring my 3 minus 3 out, bracket to pin. Then, so I'm kind of writing it again where I will solve the back one. That is the minus 10. Minus 10 out of 3 minus 1. So I'll solve that one where I'll get 3 minus 1. So which will be minus 13 out of 3 bracket close. So having this, I will then apply the minus 3 on both of them. Yeah, so
Now you are opening the bracket.
yes, I'm opening the bracket.
Okay.
So I'll have minus 3 bracket to be x plus 1 all square. Then the last one will be plus 13.
Exactly.
So in order to bring the minus at the back, so I will rewrite it and bring the 13 in front.
Exactly.
Minus 3x plus 1 all square.
Absolutely. Well done. Well done. So this is the answer to the C. And we're doing the same thing. We're doing the same thing. So even here, I didn't rewrite it well. So there's the question that was given. Now we look to see that the coefficient of x squared is not 1. So we need to factorize. So even here, he didn't even add it to the 10. He did it only for the x's. He did a minus 3, 2x plus x squared. Then inside there, what he did was, now you have x, so put this one, complete the square inside just this one. So b is 2 divided by 2 will give you 1. So we have x plus 1 all squared. Then the same b, whatever you did to b, we subtract it. So what did we do to b? We finally got 1. So subtract 1 squared is still 1, so it's minus 1. And after doing this, he expanded the bracket. So the 10 is here, minus 3 x plus 1 all squared. This multiplying this plus 3. And grouping like terms, we have 13, this plus this 13 minus all of that over here. So quite different from what our brother did, but the answer is still the same. The answer is still the same, but the underlying principle is that first factor, if the coefficient of x squared is not 1, do a factorization. You can make it affect everything. Or if you are good enough, you can do the small part and continue like that. If not, please do everything like what our brother did. So when you make the coefficient of x squared 1, the next thing is take the b part. Take the b part, half it. Well, let me see, divide by 2. Add x to it, all squared. That is your first part. So in this case, this b is 2. Coefficient of x is 2. 2 over 2 is 1. That's where this one is coming from, all squared. And 2 over 2 all squared. So 1 all squared is still 1. Yes, we subtracted it. And here, expand the brackets and then move on to the final answer. Solving a simple quadratic equation. The solution for the equation x squared equals c are x equals square root of c and x equals minus square root of c. So, this one, let me put it in layman's terms. When we want to make x the subject, now here is x squared, but if we want to make x the subject, we have to take square roots of both sides. And now c becomes a plus or minus square root of c. So that's what I'm trying to say here. When you take a square root of both sides, it comes with a plus or minus. So what was the solve the equation x squared equals 5? What will you get? You want to make, okay, let me say, you want to make x the subject. You want to make x the subject. But that, well, I don't think that's how the question would be asked. So it is plus or minus, that's what it's saying. So you can get x is equal to square root of 5 and x is equal to minus square root of 5x. And the b part is the b part. Is the B part. Solve the B part.
The B part will be s equals to 4 minus root 5 and s equals to 4 plus root 5.
Exactly. Exactly. So this is equal. So okay. That is a plus or minus square root of 5. And the B part should get 4 is equal, x is equal to 4 plus or minus square root of 5. Yeah, write it this way. Or you can expand it like this. So as we saw in the preceding example, is there a question? As we saw in the preceding example, if a quadratic equation is of the form x plus or minus a all squared equals c, then we can solve it by taking the square root of each side. In an equation of this form, the left-hand side is a perfect square. So we say that having something of this form, something inside all square, is a perfect square. The square of a linear expression in x, if a quadratic does not factor readily, then we can solve it using the technique of completing the square. This means that we add a constant to the expression to make it a perfect square. Example, to make the expression, this expression, perfect square, we must add 9, since this will result into this. Don't worry your head too much where the 9 is coming from. So since if we add 9 to it, get this. Now if you expand this, you get this whole thing, x squared minus 6x plus 1. So it's trying to say that to get a perfect square, it should be of this expression. So the method of completing the square, an expression such as x squared or x plus 2 all squared or x minus 3 all squared is called a perfect square. If x squared is equal to 3, then x is equal to plus or minus square root of 3. If x plus 2 all squared is equal to 5, then x plus 2 is equal to plus or minus square root of 5, and x is equal to minus 2 plus or minus square root of 5. So it's just solving this expression. Hence, if a quadratic equation can be rearranged so that one side of the equation is a perfect square and the other side of the equation is a number, then the solution of the equation is readily obtained by taking the square root of each side, as we have seen in the example. The process of rearranging one side of the quadratic equation to obtain a perfect square, so in the form of this, before we solve it, is known as completing the square. Completing the square. Okay. So we have this example, x plus a all squared is equal to x squared plus 2ax plus a squared. Therefore, to make the quadratic expression x squared plus 2ax into a perfect square, it is necessary to add half of the coefficients of x all squared, what we have been doing. So 2a over 2 all squared, or finally we get a squared. For example, x squared plus 3x becomes a perfect square by adding 3 over 2. So we take the coefficient of x, half it all squared. So now we have what? X squared plus 3x plus 3 over 2 all squared. And in this form, we can get x plus 3 over 2 all squared. I have made this into a perfect square. So like we've been doing, in general, to make any expression of the form into a perfect square, add a b over 2 all squared, which is a square of half of the coefficient of x. Add it to it, and then you have your perfect square. You have a perfect square. So now I want to go back small to this. Now, please, you understand where the 9 is coming from?
Yes, madam.
Yes, please.
Okay.
Yes, please.
Okay. Yes, please. Thank you very much. Now, I want a lady to explain why it is 9. Why is it 9?
Madam,
Why did you, go ahead.
okay, because when we expand it, we'll multiply the 3 by itself and to give us 9. We'll square that is square. When we expand the bracket, we'll
I know.
square it.
When the fact is, when you expand this, you get this. It is identity. Identity expressions. When you expand it, you get this. But then forget this one. Forget the x minus 3 all squared. How do you think this 9 came?
By squaring the 3. Anna.
So it came as a result, like what the last thing I said. You take the b, divide it by 2, and square all of them.
Okay.
So I have minus 6 divided by 2. What does that give me?
Minus 3.
Minus 3 all squared is what? 9.
9.
Exactly what it is saying. That is how to complete or get something into its perfect square. So this may be given. This may be given, and you want to make it a perfect square. How do you get it? So back to here, you only have this. The question can be x squared minus 6x. Make this a perfect square. And this is the answer it is looking for. So this, because you have seen the 3 here, it was easy for you to say 3 squared is, but then from here, this is where we add the 9 to it. It is this b, the coefficient of x. You have it all squared. Please don't forget this process. So that is what.
So, madam, the question will come without the like the 9 parts. So we would have to divide the b over 2 and then square it.
Exactly.
Okay.
It can give you this or give you that. So the expression that was given was just this part.
Okay.
X squared plus bx. So how did you get this to finally complete the square?
Okay.
You understand? So it's just watch your b. You watch your b divided by 2 all squared. Now when you have this, it is easy to get this. And if you can remember what we have been doing, the first part of the expression before we look at the coefficient, just x plus b over 2 all squared.
Okay.
Okay, so we have examples here. Solve quadratic equation by completing the square. Solve each of the equations below. So I think the way he set his questions are also in the book there. Solve each of the following equations by completing the square. So you have A, B, C, D. You need to complete the square. So we'll go through the first one, and then we'll do the rest. So this is a simple way. If you can keep these steps, it's just the same thing. If you can keep these steps in mind, you are good to go. So this is the equation that was given. 2x squared, sorry, 2x squared plus 5x equals 3. The very first one, 2x squared plus 5x equals 3. So this one, the first thing is divide the equation by a. Divide the equation by a. I did this, if you follow this, honestly, there's no way a coefficient of a can be 2. But sometimes, because most of the time, you get your x squared, x squared, x squared. When there is 2x squared, you may be tempted to forget the 2. So I did this step so that if the coefficient of x squared is not 2, you will not forget. So the first thing is always divide the equation by a. If it is 1, you get back the same thing. If it is not 1, you would sort that one out. So the first thing is divide the equation by a. So in this case, dividing it by a, we get x squared plus 5 over 2x equals 3 over 2. And the aim of it is to make the coefficient of x squared 1. If it is not 1, you can't continue with completing the square. It has to be 1. So first thing always do is to divide the equation by a. Now put constants to the right. Put constants to the right. Put constants to the right. So the constant here, actually it's already on the right hand side, so no problem. But you realize in the other questions, they were all equal to 0, equal to 0, equal to 0. Meaning the constant was on the left hand side. Don't forget it's constant to the right. This situation was already there, so that is fine. Now add b over 2 all squared to both sides. Add b over 2 all squared to both sides. Add it to both sides. So we have x squared plus 5 over 2 all squared plus 5 over 4. And I hope you know where this 4 is coming from. 5 over 2 divided by 2 will give us 5 over 4 all squared. And then I add the same thing, 5 over 2 all squared to the other side. This will result in the left hand side still remains the same. Simplified what is here and you get 49 over 16. 49 over 16. And what I did here is a normal 3 over 2 plus 25 over 16 over 16. The least common multiple or denominator is 16. 2 will go into 16 8 times. 8 times 3 is what? 24. 16 will go into 16 1. Multiplying 25 is 25. So I have 24 plus 25 all over 16. And this will result 24 plus 25 gives me 49 all over 16. So it is this part that I have simplified to get 49 over 16. No magic. Now to this part. If you see the way this part is, we can easily put it into a perfect square. When we take the x and this all squared. So let's take that and then 5 over 4. Oh, okay, I'll say all the squares, put them into bracket all squared. So all where has squares, all those that have squares, them together, all squared equals 49 over 16. Now this brings us to where we're doing one, like we're trying to make x the subject. So x is equal to x squared is equal to 5. And we get x is equal to plus or minus square root of. This is what we are doing here. So in this case, x plus 5 over 4 is equal to Oh, did I forget here? Okay, so the square root came. I didn't really bring the square root. The square root came. Square root of 49 is 7. Square root of 16 is 4. But the plus or minus is still there. So after taking the square root of 49, I get the 7, 16, 4. So I end up getting this. And then, so that's, mostly that can be your answer, or truly make x the subject. So take the 5/4 to the other side. You take the 5/4 to the other side, that is it here. And then you can go ahead and simplify. So simplify where your 7/4 is positive, you get 1/2, or your 7/4 is negative. You simplify, you get -3. So simple computing the square or solving the simple quadratic equation, please always go through the steps. Start with the equation. You divide through by a to make the coefficient of x squared 1. Put all the constants to the right. Put all the constants to the right. Add b/2 all squared to both sides. Now you realize that here it's a slightly different from where we were subtracting, because you have put all the constants to the right side. All you need to do is add to both sides. And then you simplify downwards. The point is, when you get here, all the squares, target them, put them in one bracket, all squared. You have completed the square. The rest is simplification. Okay, so can we do the second one? The second one is 2x squared plus 9x plus 8. We want to
Hello, madam.
Hello.
Please, looking at the first example, we have x squared, like the step that we are supposed to add the b/2 all squared to both sides. Looking at the second term, we have 5x/2. If we are to take the coefficient of the x term, which is b, that is 5/2. In your case, it's I don't know why you had 5/4 all square.
We have to take the coefficient of b and divide it by 2 before we square it.
Yeah. And taking 5/2
and dividing by 2
squaring
again, what do you get? Divide 5/2 by 2, what do you get?
Oh, okay. 5/4. Thank you.
So this is the second one. The second one is saying that 2x squared plus 9x plus 8 is equal to 0. So the same step, you divide through by a. Divide through by a. So if you divide through by a, we have x squared plus 9/2x plus 8/2 equals 0. Put constants to the right. Put constants to the right. So what do we have? We were supposed to be x squared plus 9/2, and then I can delete, I guess. And that will be what? -4, isn't it? Let me keep it this way. Yeah. -4. So I put the constant for the -4 is coming as a result of this 8/2 will give us 4. So putting constant to the right, it become -4 at the right hand side. Then add b/2 all squared to both sides. The coefficient of x is 9/2, so I get 9/4 all squared. I add it to both the left hand and the right hand side. And then simplify the right hand side going down. So this is just one here. Now to this part, look at the squares, put them together all squared. So x plus 9/4 all squared. You have completed the square.
No problem. Hello.
is equal to 17 over 16, the simplification.
Hello, madam.
Hello.
Yeah, we're looking at, I think, where we have x squared plus 9x over 2 plus bracket 9 over 4 squared. My problem is where you got the 17 and the square of 4 to be 16, but it's 17. The 9 squared, 9 over 4 squared plus 4. I think if you can get that place back for me, it'll be okay, because my network isn't all that stable.
Yeah, so we are doing this part. We
Yeah.
have minus 4. Please, I just hope you have a pen and paper. Minus 4.
Yes, please.
Okay.
Okay.
Plus,
Yeah.
you agree 9 squared is what? Is it 81? Oh,
81.
wait. 9 times 9 is what? 81.
81, yes, please.
Okay. 81 over what? 16, isn't it? 4 squared is 16.
Yes.
Okay.
16.
Now
Yeah.
we are simplifying. So now I have minus 4 plus 81 over 16. I want to put them together. The least common multiple is 16.
Okay.
So 1, the minus 4, I'm taking it as minus 4 over 1. 1 will go into 16 16 times. Multiplying minus 4, what do I get?
Minus 4 over 16 plus 81 over 16.
64. And what do we
Okay.
get? Do we get 64?
My network is really disturbing me.
Oh no, 16. I'm saying 16 multiplying 4. Is it 64?
Yes, 64.
16 times
Okay, it's
4.
64. So I have minus 64 plus 81.
Minus 64 plus 81.
It gives you what? 17.
Okay.
Is that clear?
Yes, please, madam.
Okay. So it's just simplifying that part that is giving us what is on the right hand side. So when you solve this, you get 17 over 16. And that is just what is here. Now this part, I'm saying look at all those with the squares. Then put them together. X plus 9 over 4 all squared is equal to 17 over 16. And then we want to make x a subject. So take the square root of both sides. You get x plus 9 over 4 is equal to plus or minus. I've already taken the square root, you get it. So when you get this, you bring the constant the left hand side to join what is on the right, and then we simplify. So you can get plus 1.0308 plus 9 over 4, or no, minus, this one becomes a minus 9 over 4, or minus 1.0308 minus 9 over 4. So it's either we have this, the 9 over 4 is a 2.25. So it's either you have this or you have this. And then if you leave it like this too, it is fine. If you leave it like that too, it is okay. All right, so
So, madam, please, I have a question.
that's why
Please, so if I am correct, then it means all what we did previously were to arrive here, because I remember with the first one,
exactly.
with the first one, we solve completing squares. This one too. So I was confused when you were asked to get the completing of square. So initially, I even solved it using the first procedure. So it was when you brought this, and I realized that I wouldn't, I will not use the first procedure, but rather I will be using
I
this
feel
one.
this one is simple.
Okay.
This is simple. Yeah.
So
Because
it means when you are asked to solve the completing of square, you need to use this procedure.
if this is simple for you, that's fine.
Okay.
That's good. That's fine. But no, sometimes you may forget. See, my problem is the science. It's not like you don't know, but the minus and the plus. So add here, subtract here. There's add here, those ones are a bit. But when I'm doing the same thing for both sides, that is fine. So all of them, you will arrive at the same answer. Include the one that you are comfortable with. But with this one, I think the steps will be easy to remember.
Now, please, I'm talking about the identity one. No?
Yes.
That one too, the question was asked that we should complete the square. And this one too is asking completion of square. But the solution of this one, where you end, I mean, the end result of this one is different from that one.
Yeah, so in terms of that, even if it's the other one, meaning possibly he wanted this part, but then don't worry yourself. If you solve it and you oversolve it, you lose nothing. You understand? If you solve it and you oversolve it, you lose nothing.
Okay. So
Hello,
when you are
madam.
asked solving completion of square, you should go by this one, and in order to be at the safer side.
Yeah, you can use this one. Like I'm saying, maybe somebody, the other one is simple. Please, you can go with that one.
Okay.
So
Madam.
to the third one, yellow.
Please, when A is 1, what do you do?
You end up getting the same answer. So that step is like you did not. So I am saying that I put these steps together so that every time you do it. So every time divide the equation by A. If A is nothing, you end up getting your normal equation. But then if my point is mostly if you don't bring this step and A happens not to be 1, we can forget. Me, it is the experience as a student, as teaching student, that's what I'm using. And the exam's condition, the coefficient we may forget. That's what I'm saying. Even the B that we use and divide, you only watch the B and you watch the 5, forgetting it is -5. So when you divide the equation by A and A is 1, it's like you did nothing, but you have gone through it. So that is on the safer side. There can be situations like, see the first one, the second one, the last one. The coefficient of x squared is not 1. So you have to do something before you continue. But then sometimes in teaching, you realize that sometimes the reason why students will fail is when I am teaching and I teach with only x squared, x squared, x squared. And the exams come and I bring 2x squared. Students will forget and 2 and work with the x squared. And that will make their answer wrong. Because most of the examples that we'll be solving x squared, x squared, x squared. So this step, divide the equation by A. You will lose nothing if the coefficient of x squared is 1. You will lose nothing. You still get back the original. You lose nothing. But then once you have made the habit that divide by A, you are on the safer side if the x squared the coefficient of x squared is not 1. Because under Eisen's condition, we will be tempted to use x squared and not what the question is saying. So just follow the steps. So the third one. The third one, can somebody give me the answer? I think the solution is in there, but can somebody give me the answer? Put the third and the fourth one. Please solve it. If you have written the question, let me go to one of the solutions that we looked at so that you know the steps. We are doing the C, x squared minus 8x plus 13. Somebody can try the D, 3x squared minus 12x plus 6. So these are the steps. If somebody else can give me the answer. I wish the answer would come from my ladies. Anybody? Is anybody done?
Yes, please, with the third one.
So x is equal to what?
X is equals to minus 4 plus root 3, and x is equals to 4 minus 4 minus root 3.
3, exactly. Please, I hope you did not look inside the model. I hope you solved it.
Yes, please, I solved it.
Okay, so this is it. As somebody is solving the other one. Somebody is solving the other one. Let's go through it together. So this is the equation that was given. The next step says divide the equation by a, and you realize that here nothing happened because a is 1. So say put constant to the right. So we have x squared minus 8x equals negative 13. Add b plus 2 all squared to both sides. So b is this minus 8 over 2 all squared minus 8 over 2 all squared. We add it to both sides. And here we get minus 4 all squared, solving whatever is here or simplifying it. We get 3 get 3. So put the square together. X minus 4 of 3 is equal to 3. Making x the subject, we end up with x is equal to 4 plus 4 plus or minus square root of 3. X is equal to 4, or x is equal to 4 minus square root of 3 plus square root of 3. So this is what we get. And this is what we get. Please, any question before we move on to the last example? So for the last example, this is what we have. 3x squared minus 2x plus 6. If you solve it, kudos. You have this equation, and what you have to do is divide the equation by a. A is 3. So dividing 2 by a, 12 divided by 3 is 4. 6 divided by 3 is 2. So we end up getting this. So you realize that this step, sometimes you do nothing. Sometimes it will help you to avoid certain mistakes. So we divide through by the coefficient of x squared, which is 3. We get this. Put constant to the right, so we end up getting x squared minus 4x equals minus 2. Add b over 2 all squared to both sides. B over 2 is minus 4 over 2 squared minus 4 over 2 squared. This one, what we get is x minus 2 all squared. That will help you. Please don't open the bracket. If you open the bracket, you find yourself wanting. Don't open, because you are going to open the square. So x minus 2 all squared is equal to, after simplifying the right hand side, we get 2. Trying making x a subject, we get plus or minus square root of 2, so we end up getting x is equal to 2 plus or minus square root of 2 for any of x. So a quadratic function f of x equals ax squared plus bx plus c can be expressed in the form ax plus h all squared plus k by completing the square. The graph of a quadratic f is a parabola with vertex hk. The parabola opens upward if a is greater than 0, or downward if a is less than 0. So we want to express this equation given in standard form, and we're saying that if this expression is given and you're asked to express it in standard form, you can use the completing the square method to express it in standard form. So we express in standard form by completing the square. We need to convert the coefficient of x squared to 1. How do we do that? Factorize it from the terms involving x before we complete the square. So we have this, we factorize just that part, plus 23. Then we start completing the square by adding half of b all squared to what is there and subtracting. So it's now went back to the old one. So x squared minus 6x, then we add this b divided by 2 all squared. We get minus 3. Minus 3 all squared is the one giving us 9. So we add it here, we subtract it from the constant. And then, or you can follow what we just did. And then we put them together. So we, after factorizing and simplifying, we get this, which is the standard form of the equation that was given. Now, this standard form is saying that, looking at it.
Hello, madam.
Hello.
Please kindly go back a bit for me. The previous slide before you. Yeah, please take us through this one again.
Okay, so we are still in the method of completing the squares.
All right.
So we want a question with the function is given, and it's saying that we should put it in standard form. Standard form can be achieved by using the completing the square method. Using the completing the square method. So here he used the very first approach before I came in with this one.
Okay.
Okay. So using, if you should cast your mind back, what we did was at a point in time we will factorize. Because the
Yeah.
coefficient, if the coefficient of x squared is not 1, you can't continue to complete the square.
All right.
That is why here it did the factorization. But for mine, you realize that I said divide through by the coefficient of x squared.
Mm-hmm.
Yeah. So here it did a factorization. Then it completed the square of what is inside, the rest. And if
Okay.
you can remember, that's where you add and you subtract. If you follow my method, it's just add to both sides.
Okay. That's why I got confused. Right? But you don't worry. I
Okay.
joined the lesson at the later
A bit
part, so you don't
late.
worry. You can
Okay.
go ahead.
Okay.
I'll find
Okay.
time to go
So
back to revise.
yeah, that was the initial method, but you end up getting like the same answer, is the same concept anyway. So for this, after factorizing the 2 out from just the 2x squared minus 12x, not the constant, we end up getting this. Then we pick the b divided by
Yeah.
2 all squared. We add it to what is in the bracket. We subtract it from the constant.
Okay.
So minus 6 over 2 all squared gives us 9.
9. Yeah.
So we add it here, we subtract it here.
Okay.
So in the parentheses, then subtract, even here he's saying subtract 2.
So why we have 2? Okay. Okay. I wanted to ask why we are having after the 23 minus 2. Yeah, I wanted to know that one.
That I feel possibly, I don't know where his 2 is coming from, because if we were to factor, if everything
It seems madam, let me it seems you see the 2 is outside the parentheses and it's affecting everything inside the bracket. Therefore, if you are to what do you call it, subtract the 9 from the 3,
his
then
method,
the 2
his method is a bit confusing. So his method is a bit confusing. The one in the bottom.
Right.
So you
All right.
realize that it's like he said the 2 is the value factored out to make the coefficient of x squared become 1. So this 2 that came to multiply the b minus 2 all squared is coming from this 2.
Yeah.
It's coming from this 2. So if I should cast my mind back to what we were doing, where we just subtracted it, that time the square root, the coefficient of x squared was 1.
Okay.
I believe at that time, if I can go back to that time, I'll come back to one of these. This. To see something. Okay, so I think is the first one that we were solving.
Okay.
The first one, it is this. So this first one, you realize that what he did was pick the b divided by 2 all squared. And then when it comes to the 3 here, how did we get this 3 here? It was still this plus 1. And then we subtracted the, what we did was the b. So after the 4 over 2 all squared is the same thing that we did over here, all squared. We subtracted it, so it's like we have added it here. The constant here came, and then the b over 2 all squared. But here we did not see any number multiplying it because the coefficient of x squared was 1.
Yeah.
You get it? But
Yes.
then now where we are now, you realize that here the coefficient of x squared is 2. It wasn't just x squared. So I think if the coefficient of x squared is not 1, then you have to multiply when you are subtracting.
All right.
And then he got that. So what he gets from it is 2, and then he will do a factorization of what is given. When you get 2 numbers that when you multiply, you get 9. When you add, you get the minus 6. And it is what? Minus 3. Minus 3 minus 3 will give you minus 6. Minus 3 multiplying minus 3 will give you positive 9. So inside the brackets here, you have the 2. We factorize what was in here again. And now we have 2x minus 3 all squared plus 5. Plus 5 as a result of 23 minus 18. 23 minus 18 giving us this. So we have factored it out. Now, in the standard form, we have this with vertex, this and that. And that's what the English address says H and K. If you look back, this is our H, this is our K. So if you put it in standard form, the function is a parabola with vertex H and K, which is 3, 5. Now I think the same, I don't know if it's the same. With the same function, I think I went through using my method.
Please,
So,
madam.
hello.
Please, the function is the parabola. I really don't understand that.
So this function in this form, the ax squared plus bx plus c, it is a function, as you can see, f of x. And it's actually a curve. It's a curve. If you remember last week, go to types of function, logarithmic, exponential, whatever, and I tried to bring a diagram that represents those functions. So this function, it is a parabola. The parabola is a curve.
Okay.
It's a curve. And it is trying to say that if a in your function, if a is greater than 0, then the parabola will be like u. It will be like u. When you are drawing it, it will be like u. But if the coefficient here is less than 0, then it will be like n. We will see that in a bit. I try to get a graph to represent it. You see it in a bit. Please, we'll go on a break soon, okay? We'll go on a break soon. So if please, this method that was in the book, if this method is too some way for you, I still took it and I went by my method. I wouldn't say my method, but a simpler one. So what did you do? This is a function that was given. And the first thing I will say is divide the equation by a. So I have x squared minus this divided by 2, you get 6x, 23 over 2, you get 0. Put constant to the right. So this 23 over 2 goes to the right. And that is what we have. Add b over 2 all squared to both sides. So this minus 6 over 2 all squared, we add it to the left-hand side, we add it to the right-hand side. Then simplify. This part is just simplification. Simplify. You end up getting what? Minus 5 over 2. That is it for this side. On this side, put the square together. Put the square together. Now minus 6 over 2, I'm getting minus 3. I said, oh, open the brackets. Square, put them together. So you have what? X minus 3 all squared is equal to the simplification here. Now, what we do is the 2. We try to make x a subject. So I multiply 2 by 2. And it's not like the 2 is coming from anywhere. It is the same 2 I divided 2 by, and then end up coming back. So I multiply 2 by 2, and I end up getting what? 2 into x minus 3 all squared. I brought the 5 plus 5 equals to 0. So now, in this form, you see here, I'm not looking for x is equal to this, x is equal to this. I'm just simplifying using the completing the method square. So I'm not looking for x is equal to this. If you go on and you do that, no problem. Over solving is not the problem. But now here, there's a reason why we want to put it in the standard form. We are looking for these vertex that will enable us to plot a parabola. So this is the same thing going through his method he achieved. So you can stick to the one that you are okay with, the method you are okay with. It's all completing the square. So now our parabola has vertex h and k, which is 3, 5. H and k, which is 3, 5. So still on it now, if you have it like this with AB being your constant, the shape of the graph or the function is a parabola. And I have said that if A is greater than 0, it opens upward like U, and the function will have a minimum value. If it is less than 0, the parabola is downwards like N, and the function has a maximum value. So this is how, when you come to minimum maximum values of a quadratic function, the question can be given. A function is given, you'll be told to express it in standard form like we did. If the first method is okay for you, go by it. If the second that I taught you, you start with the equation, divide through by a, put constant to the right, b minus a all squared, add it to both sides, and then complete the square. If you follow that one too, you can use to put the expression in standard form. And then it goes ahead to say, now sketch the graph. How do you sketch the graph? Once you have the vertex and you know the coefficient of A, you can sketch. And it goes on to say, find the minimum value of F. So before we just go on a break, we will do just this example, and then we'll go on a break by expressing it in standard form, sketching the graph, and finding the minimum value. So the first one, I use my method. I use my method because that is simple for me. So start with the equation. This is the equation given. divide the equation by A. So I divide through by A, which is 5. Minus 30 over 5 is 6. 49 over 5. So this is what we get. Put constant to the right. So I take the 49 to the other side, and this is what I get. S squared minus 6x is equal to this. Add b over 2 all squared to both sides. Both sides. So I add it. B is minus 6. So minus 6 over 2. Yeah, minus 6 over 2 there. If I simplify just what is in the bracket, I end up getting minus 3. So in completing the square here, put the square together. X minus 3 all squared here. I do a simplification of this. Simplify, just simplify this. And you end up getting minus 4 over 5. Minus 4 over 5. And what do I do next? Now here, what I do was, the target is not to get the values of x, but to get a vertex. So I multiplied through by 5, and I brought the minus 4 again, just equating everything back to 0 again. So I end up getting 5x minus 3 all squared plus 4. Now from this expression, I can get my vectors, which is this h and k. So this function has a vertex 3 and 4. We have put it in standard form. We are done. We are done. Now the second part is saying that we should sketch the graph. We should sketch the graph. So sketching the graph.
With this one, it means the operators in front of the numbers. We don't, when you are writing the vectors, you don't take
No,
into consideration.
No, don't take into consideration this one. It is just that.
Madam.
Thank you.
Hello.
Madam.
Hello.
Yeah, please. When we got to the x minus 3 all into bracket squared, in fact, I'm a bit confused of how we simply got that.
This x minus this 3.
Okay.
I agree with David because I look where the results, you get this results. I think getting to that place is a bit challenging for us. If you can take your time and then.
Please, which results? Is it this one?
I mean, this result, x squared minus 6x. Why you simplify that one? Because when you got x minus 2 into bracket, then you squared it. X minus 3 that side. That's why the problem becomes.
The minus 6x where because you said you put the x square minus 3 the bracket all square, so that minus 6x.
You incomplete. We are coming from somewhere. We are completing the square. So when you have this, you add the b over 2 all squared to both sides. This is what you get. Now this 3 is as a result of I simplified just this.
6 over 2, negative 6 2. Yeah, we get that one.
Exactly. Now to get this, when you have this, you have this.
How did you come by that? That is why we are.
This is what from the beginning. It's so I'm just saying from the beginning. I don't know if I should. Oh my goodness.
Yeah, Mr. David, from the beginning of the lesson, we were expanding.
Yeah. It is there. So I am just trying to make this a bit simple. If you have completed the square, like they'll tell you, if you have something like this, this is the identity. How did we arrive at this? We went through a process of completing the square. We went through a process of completing the square. So now that we are here, if I come to my method, if I come to my method, so this one, I don't think so. So if we come here, this one, if you come here, all I tell you is after you are done, the square, that's why I keep saying those that are square, put them together all squared. So if you should follow my method like this, if you should follow through and you get here, to get the left-hand side, the x here and whatever is in the bracket here. So I keep saying don't expand the bracket and get 9. If you get 9, you can't go on. So I am teaching like I'm teaching a child, the layman. All I say is this x here and whatever is in the bracket squared here, put it together. There's a reason behind. There's a process we went through. But maybe somebody did not understand that part at all. So you forget that one. When you get to this point, if you follow this process and you get to this point, take the x here or all those that are square, take them and put them together and square all of them. That is just what I'm saying. How we got there, we have passed that stage.
What becomes
maybe
what becomes of the negative 6x?
No, it's
Negative
not part
6,
again.
madam.
It is not part again. This, so you realize that if you should expand this, you will get this. So Tom,
Hello, madam.
yes,
Yeah, hello, madam.
I'm teaching you shortcuts and you are still worrying about some people.
So, thank you, madam.
This one and this one, when you put them together, you get this in layman's term. When you expand this back, you will get the -6 will appear. So we started with identity expressions. Whatever is here, whatever you are seeing here, this is another form. So when we started, I was like, they will give you this, evaluate this, or solve for this. You open the brackets. You simply open the brackets and you get x squared minus 6x plus 9.
Okay.
You will get this. But then what if they give you this rather and they tell you to find another expression for it? This is how we started. This is how we started. So this thing, the -6s here, it is inside here. It is there. If you like expand the bracket, it will come.
Yeah, after fertilization or expansion, you see it there.
It will come.
Yeah.
So I am just telling you, maybe all that you did not understand. We are now here. Please take the square, take the square and put them together.
-6.
So when you get to this part, don't worry about your head. Those that are half square, just take it and put them together all square. Whatever happened to the 6x, don't worry. It is inside. I know it is too much. That's why I'm trying to break it down. So whatever is happening to the -6s, my dear, don't worry. It is there. So just take the square here.
Madam, please, since we want to progress, right? Why don't we just pick one of the minus x minus 3 all squared, so that we expand it for the person to know that we are coming back to the same thing. Pardon me, I know you have taken it, but just for the sake of that person, so that you can then move ahead. So we have x minus 3
Boga, the expansion of that, I think we are all clear about that, but coming back to that is the problem. That's the only thing I think.
Coming back to which one?
What the person is saying is that about why the 6 and it's not with 43. So that's a bit for the person to understand and then we then move on from there.
Oh, okay. But for me, I thought this was quite understood that.
Please, do we understand this one?
Yes, please.
So now, if I should continue, won't I get the x squared minus 6x plus 9?
Yes.
I will get it. And that is exactly this one again.
Yeah.
When you open this bracket again, that's exactly it. So this whole thing, we have replaced it with its identity. The same thing. It is the same thing. But the process, what made us get that is what we call completing the square. Completing the square. So even if we still don't understand, I'm saying that when you get this, those that are in square, the expression, watch them, those that are in square, just put them together and square all of them. So x is here, minus 3 is here, x minus 3, all squared. Having faith that whatever you have written is the same thing here.
Sure.
So now when I get here, I want to equate this whole equation back to 0. How do I achieve that? I multiply through by 5, and then the 4 here, I bring it. Please don't multiply through by minus 5, because we don't want the coefficient as negative. So multiply through by 5, and then you bring your minus 4, it becomes plus 4. You have this. Now, out of this is where you get the vertex for the parabola. The vertex for the parabola, which is h and k. Please don't worry about the sign here. It's just h and k. So when we go on, so this function, we have put it in a standard form, which is this. Now our h and k is our vertex. So in sketching the graph, the vertex is 3 and 4. How do you know whether the graph is going to open upward or coming down? You look at A. A is what? 5. And 5 is greater than 0. So it will open upwards. That note, let it. It will open upwards because it is greater than 0. So when sketching, this will be your sketch. It is not in your notes anyway, but this is your sketch. So your vectors is 3 and 4. In the function given, A is 5. A is greater than 0. So the parabola opens upwards. The one who said he doesn't know parabola, this curve is a parabola. Okay. Then we answer the last question. Find the minimum value of C. Find the minimum value of C. Before we go on, your H as well as your K. Mostly your K is the minimum or the maximum value. Your K is the maximum or the minimum value. Now it is minimum here because A was greater than, so you end up getting a minimum value. If A was less than 0, you will get a maximum value. All of them is in the notes somewhere. If A is greater than 0, the parabola opens upwards and the function has a minimum value. If A is less than 0, then it opens downwards, parabola, and the function has a maximum value. So with what we solved, find the minimum value is as a result of the A here is greater than 0. So the last one, after sketching our graph, finding the minimum value. Finding the minimum value of the function. It is your value of K. Or in other words, put your H inside the function. Your h. So we had vertex 3, 4. Put the x coordinates inside the function given. Whatever you get is your minimum value. And what you will get is 4. So our h is 3, isn't it? Let's put 3 into this function. You have 5 into 3 squared minus 30 in multiplying 3 plus 49. The first one will give us 9 times 5 is 45 minus 90 plus 49. So let's say okay. So 45 minus 90 will give me minus 45 plus 49. And what I end up getting is 4. So all that I did here was, let me copy this finish. And the values that we had, the vertex are h, comma k, because was 3, 4. And I'm saying that if they ask you for minimum or maximum value, mostly it is this value, your k. But to let you believe it is k, or for those who want long procedure, put your 3 inside the equation. Put your 3 inside the equation. So here we have 3, and then we have 3. Now this will give me 9 times 5, 45, minus 90 plus 45. And this will give me 4. Because this side will give me minus 45, minus 45 plus 49.
Okay.
49. So this is how you can get k. But if you don't want to plenty calculation, please, your k is the minimum or the maximum value, then you are done. Okay, so let's take a break here. We will come back in 10 minutes time to continue. I hope it's fine. We'll come back here, but let me see if there is another.
It shall be, madam. It shall be.
Okay.
It is well.
All right. So I will leave this one on the screen. I'll leave this one on the screen. And I would want you to express it in standard form and find the vertex A and B. I mean, try and solve it if you can. When we come back, we will all do it together. So we will meet at 9:40. Thank you.
Please, how do we go about this one too? If somebody is doing it. David, please, how do you go about this one?
Actually, I'm still on it. I would like to finish so that I can share what I've to verify if my procedure is right. Then I can share with you. If that is okay.
Please, I just want you to just take me through how I'll start all this one. In fact, I've been quite
all right.
For
Okay. Excuse me. Just some few seconds and.
All right, thank you.
Let's go.
You know, my I don't know, when it comes to sharing my screen, then it comes to something else. It comes something else for me. All right.
But it seems you are sharing.
Yeah, I'm sharing, but what I want to do is I want to okay.
Then before you say your screen, what was your H and your K?
My H happens to be 2. The h was 2, and then the k was 5. I don't know if that is right.
Okay.
Did you get the same thing?
Me, I got half and 10.
Oh, sorry. I wrote it as 2 to the power minus 1. So sorry. It's supposed to be, which is the same thing as half, right? So it's half and 5.
Okay, me, I got half and 10.
Half and 10. How did you get a 10? Can you go through for me?
Please, it would be better if you start. Right, we are here.
What is this crash?
Give me.
Yeah.
Are you also getting it all?
Hello.
Okay, so you
it's even 9:40.
Let me.
It's even 9:40. Don't worry. And the answers I was getting was interesting, so I have to just jump in. Please, let's go over. Let's do it together. And for those who don't understand, please take this opportunity. Take this opportunity and understand. Just float. Even if you don't know how to swim, you just float for me. That's all. Okay, so the equation given was minus x squared plus x plus 2. So this is it. Now, the next step is to divide the equation by a. What is a? What is a?
A is minus 1.
Minus 1. Exactly. A is minus 1. So we divide through by a. So this becomes x squared minus x minus 2 equals 0. The next step is what? Put constant to the right. Put constant to the right. So this is the constant here, the minus 2. We take it to the right, and then we have what? X squared minus x is equal to 2. We have to add b over 2 all squared to both sides of the equation. To both sides of the equation. Now, what is b? B is minus 1. B is minus 1. These steps we have gone through several times. Please take the last chance to understand. From the beginning that we have been doing, you can equally use this process to answer all those questions. So dividing through by a puts constant to the right, add b over 2 all squared to both sides. B is minus 1. So it's minus 1 over 2 all squared. You pick your b, the coefficient of x is b. Divide by 2 and square all of them. And b is minus 1. So minus 1 divided, we have it all squared. That's what we do to both sides. We add it to both sides. Now at this point, the right hand side, just simplify. When I say simplify, break it down. So inside the brackets here, we are likely to have what? 1 over 4. 1 over 4 plus 2, simplify, and then you get your 9 over 4. And this, I think this is where somebody had it wrong and had 10.
Okay.
I don't know how you got your 10. And that was what made me jump in. Sorry. It's 9 over 4. Then the left-hand side, I said, don't simplify anything. Whatever is it that you have, put the squares together. Put the squares together. So x and whatever is in this bracket, put them together, all squared. We have completed the square.
But why 9 on 4?
9 on 4 because we simplified this. You get 2 plus 1 over 4. That's 1 over 4. So 2 plus 1 over 4 is 9 over 4. You take the least common multiple, which is 4. 1 will go into 4, 4 times multiplied by 2 is 8. Plus 4 goes into 4, 4 times 1 multiplied by 1. I don't know why this one. Are you not math students? If you have 2.
No, please.
Hey, and you're doing this one there, it's advanced. So until I'm brain.
I get it.
Where's the equation in set?
Madam, some of
Madam,
us.
with this one, I think they can use even calculator to when you key in it in calculator, it will give you the answer straight forward.
Yeah, 1 over 4. Now
No,
this
I
one,
made the denominator 2. That's
this
why I
one,
said it.
this one in class 1. In class 1, they showed me least common multiple. So what I did was, so what I did was, the down part is 4. Out of the 2, the least common is 4. Now 4, this is 2 over 1 is 2. 1 will go into 4, 4 times multiplied by 2 is 8. So it's 8. The plus will come. 4 will go into 4, only 1. Multiplied by 1 is 1. So I get 1. Now this equals, put the 2 together, 9 over 4. So if you don't even know, it is 2 over 1. Two over 1 is still 2. So this is what I simplified. The least common multiple here is 4.
Use the 4. Sorry.
4, 1 into 4, 4 times multiplied by 2, 8. 4 into 4, 1 multiplied by 1 is 1. This is what I mean when I say simplify the side. That's just what you have been doing over there. Then the left-hand side, put the squares together. X minus 1 over 2 all squared is what you get here. Now, we want to equate this whole thing to 0. Yes.
Please, I learned you said when we can then multiply through by the coefficient, the denominator, that is 4.
Yeah.
So how come?
I'm coming to that. We are not that yet. I'm coming to that. So it's just like put this whole thing, equate it to 0. How do we equate it to 0? We can achieve that by multiplying through by 4.
By 4.
Yes, and bring in the 9, which will give us minus 9. So this is what we take here.
So minus 9.
Just that in this case, I did not multiply through by 4. I just brought the whole thing, this one over here.
That's why you see, it seems some of us did that method. That's why you're having 4 and then 9.
Oh, okay. So let me go back to. Okay.
We multiply through by the denominator.
Okay.
Because you're supposed to get 8 in standard form, which will be that is what do you call it? The A into brackets x minus h all squared equals k. That's what you're supposed to get.
Okay.
So please kindly go back to where we were.
I'll go back to that. I realize that when you carefully look at this, the X, the A, it's like it is still there.
Yeah.
of this form.
Mm-hmm.
So this in standard form like that.
Becomes,
So
yeah.
when I multiply 2 by 4, there's a reason to get it in this form. Then this becomes my H and K.
K, yes.
So with what we had here, what was our A?
Our A was 2.
Our A was 5.
Okay.
With this one, our A
Yeah,
was
5.
So put it in standard form. There's a reason why I multiply to get it in that form. My A is still there.
It's still
So
there.
now this is my H and K.
Mm-hmm.
Now let's go on to the question we are solving.
Yeah.
This is a question we are solving. So when I get here, what is my A?
All right. Yeah, that's -1. So we have maintain the. Okay.
Yes.
Mm-hmm. I think you didn't stress on the fact that you have to maintain the A at the final stage.
That is why I kept saying okay. So it's not like we are just solving. Now we are putting it in that A into bracket something HK.
Okay. All right.
So as you are simplifying, you need to have the formal equation in your head.
Okay.
So you realize that I brought it here and then I said what? I multiplied through by -1.
Yeah.
So negative, this became plus. So then the actual standard form is this. My A is still there. So now my H half 9/4.
Yeah. Okay. All right. So that's then it means after.
Okay. So now looking at this, hello?
Hello, madam.
I thought somebody said hello.
You did. I think I'm giving you a feedback. So sorry. Let me turn my mic.
Okay. So now, before we go to the B and the C of the question, of this question, you realize that if you are to sketch, now we have our vertex, which is 1/2, 9/4. Is the graph going to open upwards or downwards?
Since the
Downwards.
A is it's less than 1, then it means going to be downwards.
Then, madam, if this is the case, then it means if the question is given to you, you can even identify that this one is to open downwards or upwards because of the A.
Now you are swimming. You are swimming.
Yeah.
Mm-hmm. So from when the question is given, you can straight away know that this is going to be an upward open or downward open. You know from it. So you realize that even the question,
without solving the question, you still know
you
whether.
have an idea. Yeah, you have an idea. So realize that the C is asking for a maximum value. So I am the one setting the question, and I say find the minimum value of C, meaning I don't want you to do anything there. I just want you to tell me there is no minimum value because A is. Then I know you understand what you are doing.
Okay.
Because A is less than 0, you can only find a maximum value.
Right.
If A is greater than 0, you can find a minimum value. So if I should go back to what we did, you realize that here A was greater than 0, so the question was find the minimum value. Now because A in the other question is -1, find the maximum. So what is the maximum value?
Will be that is 9/4.
9/4. No.
Exactly. I just wish my ladies are on the same page with me like the guys. Oh, the ladies.
Madam, we are following.
Okay.
Levis, where are you? I've not heard from you.
So the graph is a parabola that has this vertex and it opens downwards because A is less than 10. A is less than 10. So this is it. Not like I drew it. I just copied the section and I gave it to AI. AI designed the graph for me.
Okay.
So if AI knows how to sketch the graph, please, human beings should do better. If AI, just by giving the equation to AI has drawn the graph, and it is true. Because A is less than, you see, it is facing downwards. And the other one that
Madam, please, AI has a lot of resources at its disposal. We human beings, we don't have.
Hey, human beings. Human beings. We are the same people fighting this AI. Okay? You are now saying AI has a lot of resources.
For that one,
when you use it to do your thesis and you present and then your supervisor is talking, you now be on the side of the AI. So that is why it didn't say draw. It said sketch. This one I see it as a proper drawing. It said sketch. And all that you need is the vertex. All that you need is the vertex 3, 4. And to know whether it is opening upwards or downward, the function itself will tell you. So that is it for that. And the maximum value, like he rightly said, is 9/4. Like I told you, it is K. It is K. Don't worry yourself calculating. It is K. 9/4. You are done. So to find let's say a question doesn't require you to put it in standard form and sketch, but it goes like just find the maximum and minimum values of this quadratic equations. What you need to do is, if that means you are not going to go to the completing the square method, you don't go to that. What you can do to find the maximum and the minimum values is that x is equal to minus b over 2a. When you get your x, put the value of x back in the equation. That will give you your minimum value. That will give you, and you realize that when the minimum value or the maximum value you have been looking at, carefully, if you cast your mind back, it is always the y coordinate. So HK, the K is the y coordinate, and that is the maximum or the minimum value. So if you don't go through all that to get the vertex, and you are just to find the maximum and the minimum values, x is equal to the formula minus b over 2a. A and b, you can find them in the function. So in this, the first one, a is 1, b is 4. That in the function, we get x equals minus 2. When we put minus 2 back into this equation, we will get what? Minus 4. So the minimum value. And why is it minimum value? The question says find the minimum or maximum values for the quadratic. Why are we saying this is a minimum value? The minimum value is 4. Why?
Because it's less than 0.
Mm-hmm. I'm happy I'm hearing a lady's voice because because
it's less than 0.
hey, which one is less than 0?
The minus 2.
The Then this minus 2a. Oh
Hey.
no.
The A. Hey.
When you check the a value here, the a value here is greater than 0.
One.
So it's a
Greater than zero.
minimum value.
Sorry.
It's even here. Since a is equal to 1
Greater
and it's greater than 0, it's a minimum value. Now, when you look at the function g of x would have a maximum value because minus 2 is less than 0. So the parabola open downwards. But here it didn't ask you to draw, so no problem. So what's the maximum value for g of x?
Negative.
It's negative 2. Okay, so x is equal to minus b over 2a.
Negative.
B is what? 4. So minus 4 over 2 into minus 2. So x is what? 1. If I should put 1 in the equation, sorry. I should put 1 in the equation, I get minus 2, 1 squared plus 4 into 1 minus 5. And I'll get what? Minus 2 plus 4 minus 5. 4 minus 7 is what? Minus 3. It's minus 3. So from the minus 2.
No, madam.
Yes. Okay, so the A there we have done it. Okay. The A there we have done it. So this one, for the B, it calculates the x 4, but the formula is minus A. So minus 4 over 2A. A is minus 2. So we get minus 4 over minus 4, which is 1. And we put 1 back in the equation. And then we end up getting minus.
I didn't solve it earlier. I thought my network was misbehaved. When I came back, I thought we were just taking the coefficient of the x, like the a, and then we just.
No. The coefficient. Okay. The coefficient tells you whether you are going to get a minimum or a maximum value. So you realize I'm not the one going to set a question, but a question can go like, will this function have a minimum or a maximum value? This function has a minimum value, true or false? So you will use the coefficient of x squared to determine. And that same coefficient of x squared tells you if the graph is going to open upwards or downwards.
Okay.
And then to get your maximum or minimum function, the minimum value, if you don't complete the square going through those steps, if you don't do that, this is how you can get it by solving for x using this formula. And then whatever you get for x, put it back in the formula. You get the value you are looking for. So this the x looks like your x coordinates. When you put it back, that you are solving for y, you get your y coordinates, which is the minus 2. Okay. We are moving on. Any function, we move on to polynomials. We are done with quadratic. We are moving on. No, the quadratic are still polynomials. I don't know how the title of this thing was given. I said polynomials. Any function. Sorry. Any function defined with degree n of the form a n x of n plus a n minus 1 x n minus 1 all the way to a0 is a polynomial function where n is a non-negative integer and a of n is not equal to 0. The numbers a0 through to an are called coefficients of the polynomial. The number a of 0 is a constant coefficient or constant term the number A of it, the coefficient of the highest power, is the leading coefficient, and the term ANXN is the leading term. Polynomial functions are called polynomials. So the first one we see is zero of polynomials. If P is a polynomial function, then C is called a zero of P if P of C is equal to 0. In other words, the zeros of P are the solutions of the polynomial where the equation equates to 0. Note that if P of C is 0, then the graph of P has an x-intercept at x equals C. So the x-intercept of the graph are zeros of the function. So if B is a polynomial and C is a real number, then the following are equivalent. C is a zero of P. X is equal to C. X minus C is a factor of P of X. C is an x-intercept. To find the zeros of a polynomial, we factor and then we use the zero product property. We met from the beginning of today's lecture. The zero property, we saw it. For example, to find the zeros of this, we have to expand, or in other words, factorize. Now, when we factorize, each and every one of them are factors of the equation. They are factors of the equation. So x minus 2 is a factor of the equation. Likewise, x plus 3 is also a factor of the equation. Now, 2 is a zero of P. 2 is a zero of P. Because if we put 2 in there, the whole equation can run to 0. If we put 2, x equals 2, the whole equation will run to 0. So let's put x equals 2 in there. This will give us 4 plus 2 minus 6. The whole thing will be 0. So 2 is a zero of P. Likewise, minus 3 is also a zero of P. This is what the zeros of polynomials are all about. So let's try and find the zeros of the following polynomials. The first one.
The first one, 2. Anna? 2, 6. What else? 2, 6.
Is that all?
2 minus 3.
2 minus 3, exactly. 2 and minus 3. If you put minus 3 in there, this will give you 9 minus 3. 6 minus 6 is 0. So the zeros of the first one is x equals to x equals to minus 3. The second one.
And please, the first one.
2 minus 2. The second one is 2 minus 2.
Okay, I'll come to that. Somebody's asking a question.
Please, the first one. Please go by.
So if you want to do it, I will suggest please factorize first. When you factorize, you get the factors. Out of the factors, you get the zeros. So the first one, if you have to factorize, you will get the x squared plus 2x minus, so it will be, let me do the minus 2x plus 3x 6. If I say factorize, look for two numbers. Now when you multiply, it give you the constant. when you put them together, add, you will get x. So you realize when I was doing it, I did a plus 2 minus 3. And minus 3 will give me minus 6 here. That's why I had to change the signs. Minus 2 plus 3 will give me a positive x. Minus 2 multiplying 3 will give me negative 6. So in this case, my factors are x minus 2, x plus 3. This becomes my factors. Now from my factors, I can get my zeros, of which x is equal to 2 or x is equal to minus 3, where I pick each one of them and equate it to 0. And then I make x a subject. So the second one.
The answers are 2. So 2 and a negative.
Yes.
Okay.
Those are the zeros of the first one. The second one.
Madam, that one I think is minus 2 plus 2. Minus 2 or plus 2.
I am sure your answer is right. Please take us through how you got it.
Now, when you factorize the x squared minus 4, they are all squared. So you are going to get x minus 2 all in brackets, and also x plus 2 in brackets. Then this implies that x equals minus 2. When you take one of them, x equals minus 2, and the other one x equals 2.
So,
Madam.
Yeah, he needs a step, but you can still factorize. If you are to do this, the two numbers that when you multiply, you get minus 4. When you put them together, you will get nothing because x, you can see x there because it is not there. Those two numbers are minus 2 and plus 2. Minus 2 plus 2 will make the coefficient of x 0. That's why it is not there. So in natural sense, we have x squared minus 2x plus 2x minus 4. This is the fracted one. These two numbers, minus 2 plus 2 gives you 0. So this thing is not there. Then minus 2 multiplying 2 will give you minus 4. So if you are thinking you can factorize using the same method, it is there. So we do that, and then you get, so if these two goes, you end up getting what you have. So it's x minus 2, x plus 2. Now, having the factors like this, you can get the zeros. X equals 2, x equals minus 2. The last one.
Madam.
Yes.
Yeah, please, with that, what immediately came into my mind was just to make the x the subject, right? So x squared is equal to plus 4. X squared is equal to 4. Then I found the square root of 4, which gives us
plus or minus
plus
2.
2. Yeah, plus or minus 2.
Okay. But make sure that process we are using is consistent. Can I use the same product for the first one and the last one? The same process. Make sure it is consistent. Okay.
So,
The
Madam,
last
what about with that one, writing the equation in a way that will favor you? That is writing it s squared plus 0x minus 4
I
in
don't
order
know.
for you to.
Yeah, you can do that.
Okay.
This is smart. You can do that, but make sure you are not changing the question.
Okay.
All right. So the last one
The last one is 1 and 2.
is 1 and 2.
Yes,
Is
please.
how you get it? Is how did you get it?
So with that one, we find a number, the factors of 2, which when multiply you get 2, when added you get -3. So we will write it as s. That one is cube. Oh,
That one is cute. So you see,
I
I
thought
always
it was
tell you,
square. Sorry.
Until when I
Okay,
was
madam.
telling you
First,
always divide by the coefficient of A, is because I know the mistakes that students can make. Not the mistakes,
hello.
not that you don't know. I know you know. I know you know. But under certain kind of pressure, you can forget. You can forget.
Hello, madam.
You see, because always we work with S square, S square, S square. Now when you see 2S square, you forget the 2S to continue with what you. These are all under exams condition. So what's S cube? So the first thing you can do is put it in a quadratic way. Factorize x out. Then you get what is in the bracket. Then you can go ahead with what you are saying. Where you have x out, then inside, now you can have what? Your x squared minus x minus 2x plus 2. No, it's close to say, okay, that's all. It's okay. Please, I hope you understand.
Hello, madam.
Is it yes or no?
Hello.
But up to this point, it's all right. But let's continue.
I think somebody is lost. So
Yeah,
this is what
madam,
I
please.
factorize x out.
Can we divide 2 by x?
And where are you going?
No, the x cube minus 3x squared plus 2x.
That
If
is
you
what I'm saying.
divide
What is
each
your
function
motive?
by 3
What
by
is your
x,
motive?
so
What
that we
is your
can
motive?
get a quadratic function like we get x squared minus 3x plus 2 instead
What are
of
you
doing the
dividing? No.
factorization.
Why are you dividing to?
Because of
Dividing
the x
through,
cube.
that's
Yeah.
dividing through will take you anywhere. You need to factorize. Dividing through wouldn't take you anywhere. We are not even going across the equal to side. For you to say divide through. So if you divide through by x, you have done nothing. The best thing to do is to factorize. When you factorize, like we have done here, x is out. What you have in the bracket is a quadratic, and you can go ahead and solve it. So it's not divide through, it is factorize.
But from here, what do you do?
Okay, so from here we still go on.
Okay, let me see. It brought me to x out, then parentheses open, x minus 2, bracket close, and then x plus 1 under brackets. Sorry, x minus 1 again.
That's x minus 1.
Yeah. So x out, x minus, then bracket open, minus 2, x minus 1. Yeah.
Yes. So yeah, you get this. Now the zeros. The zeros
How do you find the zero?
is x equals 0.
0, yeah.
Because when this x is 0, all of them will be 0. X is equal to 2. All of them will be 0. Another one, x equals what?
1.
1. All of them will be 0. So these are the zeros.
And 3
Okay,
zeros.
so you divide through by what is in the big bracket, then x will be equal to 0. Then when you take x minus 2, you're going to get s equals 2. And when you take x minus 1, s is going to be plus 1. All right.
So those are your zeros.
Please, where are we getting the s is equals to 0?
This x there.
But my brother,
Okay,
you can see the x over there
yeah,
when
the x that
is
we factored when we started.
yes, and it is
It's
multiplying
clear.
everything in the bracket. So when you send what is in the bracket to the other side, you are going to get 0. So x will be equal to 0.
It's clear.
Yeah.
Okay, so these are the answers to it. This is the second one. And this is the third one. This is the third one. So still on finding the zeros for graphing a polynomial function. We have done one anyway. Let p of x is equal to x cubed minus 2x squared minus 3x. Find the zeros of p and sketch the graph. So likewise, we did the same. Factorize, we solve what is there, and we got the zeros. So the x-intercepts are 0, 3, and minus 1. The y-intercept is when x is 0, so when the whole thing is 0. And then here, so with the zeros, what do we do with the zeros? So we have found the zeros of a polynomial. What do we do with the zeros? Those zeros can help us to sketch a polynomial, to sketch it. So there are some rules attached. After finding your zeros, assuming these are zeros, after finding our zeros, those zeros are telling you that the graph crosses the x-axis at these states, these points. At these points. And behavior is telling you what do you do when the graph is getting towards the ends. Since the degree of the polynomial is 3, if you cast your mind back, this value, s cubed, since the degree of the polynomial is 3, which is odd, the leading coefficient is 1 positive. The graph will fall as x approaches negative. So if x is negative, the graph will fall. If x is approaching the positive, it will rise. It will rise. Behavior of the zeros, behavior near the zeros. X equals -1, x equals 0, x equals 3.
Madam, please say David kindly. He is disturbing. If you meet him.
Kindly mute.
Please, my voice is already down, so please, I beg. The graph crosses the x-axis because all the zeros have odd multiplicity. So if the multiplicity is odd, the graph will cross the x-axis. If it is even, it will not cross, but rather it will bounce off. It will bounce off. This slide is trying to tell you how to sketch. After getting your zeros, how to sketch the graph. In your notes there, I got there, it's like sketching the graph leaves it to the student. Go and find out how to sketch. But then I'm going through this. The intercept. To get the y-intercept, substitute x equals 0. You get your y-intercept. So if x is 0 and you put it into the polynomial given, you get 0. So y, when x is 0, y is 0. That will be your y-intercept. So using what we got, we can now plot our graph. So x minus 1, 0, and positive 3. Now, because they were all of odd multiplicity, they cross the line. So if you are coming from down, you will cross. If you are coming from up, you will cross. If you are coming from down, you cross. Because it is of odd multiplicity. Now, as x approaches a positive infinity, it would increase. Yeah, the behavior during the ends. If x is approaching positive, it rises. If it's approaching the negative, it falls. So going back, now x is in the negatives, so the graph falls, the end of it falls. As it is approaching the positive and the positive infinity, it rises. So after stating, if you are first drawing, you can indicate your zeros. And the zeros are -1, 0, and 3. Now, since they are all multiplicity, meaning that definitely there is a cross, but maybe you don't know whether it is going up or down, because have it at the back of your mind that it will cross. Now, going here, you realize that it is saying that how is the end behavior like? The end behavior is it will fall. So here will fall, positive, it will rise. So you can draw this side, you can draw that side. Now, in between the zeros, how do you draw it? Since you know it will cross, and it is right, it is falling here, meaning that it will rise and it will cross. Then it will cross again. Then from here, it will cross again. So you can do what is in between the zeros. You can sketch the graph in there. So we have these exercises, and then let me see something. Okay, I would want us to end on the sketching of the graph, and then next week we'll continue with writing the polynomials and all that. So,
Madam, it seems today your voice has changed. Is there a problem?
oh, from the beginning, I told you I have a cough and a cold.
Yeah, madam is not well, so.
I am well, I don't know what happened. I don't know why the cough has done my voice like that.
Madam, today your voice, there is no bass, only titters.
Hey, Jackson.
Michael
Jackson.
Yes, sir.
Hopefully, when we meet one last time next week, everything will be fine. Hope so.
Amen.
Madam, please, I want to find out, are we, for the mathematics, will we sit down and use pen to write, or you'll be using our PC to do that? Because looking at the way you are using the mouse, I'm feeling that we may also do the same thing.
Use the mouse. How?
Like the way you use your mouse, going to pick the square root and the rest, coming back to type and the rest. But I'm asking whether we will sit down and write, or you will use our PC to type.
I'm sure. You sit down and write. I'm sure you see
Okay,
that one
madam.
right.
Okay, madam. Because I'm afraid of that.
Oh, no, you see that one right. So we have another question, I think. So let's do this exercise and then possibly we'll call it a day. But the rest were very easy anyway. Find the zeros of p. If p of x is equal to minus 2x4 minus x cubed plus 3x squared. And sketch the graph. You have two of the exercises there. So you would have to go through factorization and all that to get to the zeros of p. So we factorize, we get this. Mind you, this one is x4. So when you're factorizing, bear in mind. So we factorize x squared out, get what is here. Then in here, we do another factorization. Find two numbers that when you multiply, you will get now. This is interesting. This factorization is interesting. It's interesting. So how will you factorize this?
Multiply the -2 by the 3.
Exactly. At least I'm ending on a happy note. My ladies are now swimming with me. So the first thing I'm saying, mostly, because
Was
the
it Christy that?
coefficient, because mostly the coefficient is 1, we don't tell you that what before you even look for the factors, you multiply the coefficient of this by the constant. And that will give you what? -6. -6, let me put it somewhere. -6. So you are actually going to look for two numbers that when you multiply, gives you -6. When you add, gives you -1. I can say for a fact, all the factorization we've done from the beginning, the x squared was just x squared. So even the last but one that we did, when we factored out the x, this one, we factored out the x. So our x squared became 1. So we're just looking at two numbers that you get 3. So it looks like you are always watching the constant here and trying to find the numbers. It's not just the constant, it is this multiplying this. The value that you get is what you use to find those two numbers. So with what we have here, inside the coefficient of x squared is -2. So it is rather -2 multiplying this and you get -6. So looking for those two numbers, you look for two numbers that when you multiply, will give you the -6, not 3. When you add, you get the -1. And those two numbers are -3 and 2. -3 and 2. 3 times 2 is 6. -3 plus 2 gives you the -1. So you know which one should be the minus. So this is how you factorize. And then you go ahead and you get this. You get that. So the first x here, which is x squared, if you make it 0, the whole thing becomes 0. Likewise, this x2, if you make it 0, the whole thing becomes 0. Inside the brackets there, x is 1. But if I make this 1, if I make this 1, meaning that, yeah, so if you make it 0, it's just like the first one. If you make it 1, you realize that, yeah, these ones are there. You get 2 plus -1, which will give you minus x into 2x plus 3 plus 2x plus 3. Now, if I do x equals 1, x equals 1, I'm going to get 1 squared. So inside this, let's pick this one and let me count down and paste it. So let's put x equals, for the 0, we understand. If I put x equals 0, all of them will be 0. X equals 1. This side will give me 1. This would also give me 1. X equals 1. This will turn out to be 2. 2 plus 3. This will also turn out to be 2. So I would have minus 5 here, isn't it? No, wait, I'll not have it. I have 5 plus 5. But then, yes. So 5 plus 5, I have minus 5 plus 5. Will not give me. So I have 1 into minus 5 plus 5. And this will give me, oh, sorry. And that will give me 0. Please, do you understand?
Yes, please.
Okay, so the zeros are those numbers that when you put into the equation, it will make the whole thing 0. So x equals 0. If I put x equals 0, the equation will run to 0. If I put x equals 1 into the equation, I will also get 0. Then if x is equal to minus 3 over 2, minus 3 over 2, if I should put them in here, I would also get 0. Yeah, but that one you can try on your own, but then I'll get 0 if x is equal to minus 3 over 2. So these are the zeros of this equation, of that equation. So how will these zeros help us to sketch the graph? X equals 0 with multiplicity of 2. With multiplicity of 2, meaning this here, multiplicity of 2. And that multiplicity is even. It's an even one. So because it is even, that at that 0 point, it would always bounce off, it will not cross. It will bounce off, it will not cross. But with the rest of the zeros, x equals minus 3 over 2, x equals 1, all of them have 1 as their multiplicity. They don't have this raised to the power. Or even if they have, it is 1, 1. That is what we mean by multiplicity. This one has a multiplicity of 2, which is even. The rest of them have multiplicity of 1. So at that point, they would rather cross. At that point, they would rather cross the graph. But when x equals 0, they will not cross. It will just bounce off. Then the end behavior, if you look at the polynomial, the degree is 4 and it's even. And the leading coefficient is 2, which is negative. So you would also apply. If it approaches plus or minus, it will rise or fall depending. Then the intercepts. If x is 0, put it in the equation. Y is also 0. Okay, so let's look at the drawing. With when x equals 0, the multiplicity, sorry. When x equals 0, the multiplicity is even. it has x squared, so the multiplicity was even. So we realized that when x is 0, it did not cross the line. Did not cross the line, but rather it bounced off. But with the other zeros, the multiplicity was 1, which is odd, so it will cross the line. And if they are approaching the negative, they will fall. If it crossed and it was approaching the positive, it would have risen. But once it is crossing, so I'm from the positive, if I'm to cross, I'll enter the negative, so I fall. I am from the 0, which I didn't cross because my multiplicity is even. So I just bounced off. So coming here, I was in the positive and I'm supposed to cross because here it was odd. Now, as I cross, I'm crossing from the positive to the negative, so it will fall. So using the zeros, you can sketch this graph as well. So I would want us to end here. And then next week we will continue and wrap up. I hope it is fine.
Hello, madam.
Madam, the note.
Please, now, in the exams, are you going to draw the back?
You there. When you are seeing questions like this, ask if you are going to draw. 3 questions are in the model, and you can pick a question from the model and bring.
Wow. And ask to sketch the example. Hey, this course.
Madam.
And so I was telling you that the sketching me, I looked inside your model. The sketching part, it was not taught, or like they didn't show something like this to throw more light on what the English here was saying. So I went through to show you that if the multiplicity is like this, this is what it means. The very first curve that we saw, all the multiplicity was odd. All of them were odd. So all of them we crossed. And how come this one is coming down and this one is going up? Because we crossed from the positive to the negative and there's no longer any 0 there. We are still approaching negative. So it will fall according to this one. If x is approaching negative, it will fall. If it's a positive, it rises. So negative, it will fall. Positive, it will rise. Now the in-betweens, it was supposed to cross. So if you are in the negative, you will cross. If you are positive, you will cross. That's how come we achieved this curve. All of them using the zeros. Now we had another question, which was this graph, and we got the zeros. 0, -1/2, and then 1. And we saw that the multiplicity of 0 was equal. So when we got to the 0, we did not cross, it just bounced off. It just bounced off. But when it was the others, which had the odd multiplicity, it crossed. So from the 0, we were still in the positive. So we have to cross. And when we cross, we enter the negative. So the graph will fall. Going this direction, we're in the positive, we just bounced off. So in the positive, we met this other 0. And because it was odd, we have to cross. Cross entering the negative, and so we will fall. So once you have the zeros, sketch the graph.
Madam, please with this graph, where at the right hand side, you said it will fall because it is entering the negatives, but the x values there, they are positive.
So it was supposed to be maybe sure it's supposed to P of x. So it's P of x, it's not just x. We should go back to the. Okay, so it's well, I think it's supposed to be the whole curve, not just x.
Okay.
The whole curve, the p of x, not just x. Like this should be the real thing, not just x. Or possibly, if x is approaching the negative or the positive, it's supposed to fall. If that's the meaning here. So don't I would say don't care too much about where it is going. Find your zeros and find whether it will cross or it will stay. I don't know if you understand. Find your zeros and determine whether it will bounce off or it will cross. Because you realize when we are bouncing off, we stayed where we are. We stayed where we are.
Yeah.
When the multiplicity was even and we had to cross, how do you cross? You cross from one side to the other. So if you are in a positive, you come to the negative and then just drop it. Where it is going, continue. Realize that with this one, we were crossing from the negative because here we crossed. We crossed
Okay.
and we came down. So if I'm to cross here, do I cross and come down? It'll be like I bounced off.
Oh,
So I
okay.
cross. So do not worry too much about the ends. Make sure you know the zeros and determine whether they are crossing or bouncing off.
Okay.
Please, any more questions? Any more questions?
Madam, my network was messing me up, so I think I will contact one of the guys. Because if I want to, then we have to go back and do a whole lot of things again. So,
Oh, it is even recorded, so you can go and watch it later.
oh, all right.
Okay, was recorded. Okay. Alright. So please, we'll end here. And next week, we have to continue. We have to finish this one. And then I want to teach one last unit, the unit 5. The unit 5. So please, if you can read that one too so that we can finish. But the rest for this is not, it's something that we know already. Something that we know already. So I don't think we'll keep too long there. And then we move on to the unit 5, which is conversion from one base to the other base. So we can convert from decimal to octal, octal to hexadecimal. That is all that we'll do under unit 5. And then we call it a course. Okay.
Okay, thank you, madam. In spite of your coughing, you still have done great for us. Thank you very much.
Okay. Thank you too.
Madam, please, the note.
Yes, the note. The note. Please, can somebody send me hi so that I drop the notes on WhatsApp?
Please send it in
Okay.
computing
Okay, we'll do that.
for mathematics group. Mathematics for computing. Yeah.
Yeah. So please send me hi from that. My groups are plenty, so maybe that one has gone back.
Madam.
So use the math for computing.
Madam.
Hello.
You see, with the examples that you inserted, I don't know whether it can still be found in the note. So I don't know how.
The example.
The
Please, which example?
especially the method that you introduced, apart from the one that.
Please, the examples, most of them are in the notes. Most of them are in the notes.
Okay.
I think, and I don't know, you can see that mostly it's like this. Find the zeros. This I picked from the notes. And we solved it. The exercises I gave, I think all these ones they are in your notes. The exercises, this one, it's in your notes. Just that maybe in your notes you will solve just the standard form. The sketch was left out, and then maybe you do this one. But most of the examples I took it from the notes. Just from the notes.
Okay.
Okay. Okay, thank you, David. I will drop it soon, or I am dropping it. Math for computing. So please, I have sent the notes to you. The slides, I have sent it to you. Please do go through the recordings as well. And I'm sure everything will be fine. Everything will be fine. So let's call it a day.
It has not come on. Please check it out.
That's a small pen. At my end here, it has come.
Okay, it's in now.
Yeah.
Thank you.
So we will meet next week. Bye.
Hey, I better go. Where is Jackson?
Boss, I did hear.
Hey, Charlie, it's like I don't hear of you.
Today, dear Charlie.
They do it
my
again.
right now. I was trying to find my email.
Today the mass beats Jackson.
The mass is massive.
Charlie.
Yeah, it has beat Jackson off.
And then dear Charlie, and then dear pick it.
Jackson.
David,
Sometimes my brother has to relax and let others also join. Yeah, I joined around 8:40, so I missed the whole beginning.
So David,
Charlie, you joined early. You joined early. Yeah, I just joined 2 hours later.
But we were told to start at 4, so I don't know why.
But today, Charlie, when I woke up, it's around 8:10, 8:15. So when I came, we had a slide 40 or slide 50. So, you were far ahead. So today I was, catching up a little bit. So I have to keep quiet and listen to my senior brothers.
The truth is that they platform that
they will let
they scheduled to 4 p.m. That was what he told us. Not knowing it was not ours. And then I joined earlier. So when I saw the information, I decided to leave, not knowing that it was Charlie. This today
Charlie,
I wanted to cry.
Jackson.
You have to go into the drawing board and then sit down because at home.
I will let the ladies take me through today.
So where is Mavis and then Christiana and then Esther?
Let Esther join me late. I think Esther and Mavis. Oh, Dina is also here. So Dina.
We are here.
Madam was just mentioning the ladies, not knowing. There are boys who couldn't even talk.
I said, madam felt that the ladies are, are always at the back, not knowing that we have some boys who are even at the backyard.
Today, all the boys went to the back. All the boys. The boys are
not just the back one.
And
The
the
back
ladies
one.
were doing the mass. Today the ladies were doing the mass. We the guys were behind. Oh.
I tell you.
No, but David, I think you should organize some extra classes there. See what we can do about it.
Yeah, I'm here.
Esther, please organize a classes and then you pass us through. Today, your brothers and your husbands are all lost at the bush.
Yeah, we've been talking about this, but it seems like during the week.
So, like how? Is Esther coming to Kumasi to teach us or what? I don't actually get it. Or it's going to be online.
It's going to be online. She's going to meet us at Zoom. Esther, are you there?
Yeah.
Yes, Africa they be. Yes. Bye.